Hi everyone, welcome to this new Flusso webinar. We'll be starting in a few seconds. We have a few more people joining the call, so we'll start in about 30 seconds. All right, I think we are good to go. So welcome again, and let's look at the agenda for today's webinar. So we'll have a few slides on housekeeping, meet the presenters, and what you will learn today from this presentation. Then we will move to a little bit about Flusso as a company. What do we do? Where do we come from? And you will learn about us in more details. Then we will jump into the challenges of flow measurement, current state of the art, and what Flusso is offering new in that field. Then we'll discuss our solutions, know-how, and benefits. And then we will keep plenty of time for closing and Q&A, which is really the most interactive part of the webinar. So feel free to post your questions in the chat, and we will answer them. So as discussed, this webinar today will be 45 minutes long, including 15 minutes of Q&A. You will all be muted during the presentation, but feel free to, again, post your question on the chat on the right side of the screen. And we'll answer all the questions at the end. And if we don't have time, we will answer them by emails right after this webinar. Don't stress. Don't try to take notes on your notebook. You will get the slides and the recording of this presentation usually within 2 days of the webinar. So just focus on the discussion today, and you will get everything you need in your inbox following this with this webinar. Today will be 3 people from Flusso. So Dr. Andrea De Luca, who is our CEO and founder. Andrea has been instrumental in the technology of Flusso. He's a PhD from Cambridge, and he's going to be more than happy to answer any questions that you might have at the end of the webinar. Chris Rosser, who is our principal fluidic engineer, based in Cambridge as well. He's going to be presenting on the technical part of the deck, and he's going to be answering any questions that you might have at the end, again regarding the technology itself, or the integration into your product, or any question around the developments that you might have as well. And myself, Thomas Negre, I'm in Switzerland, and I'm the head of product management for Flusso. So Flusso has been around for now about 4 years. We are a fabless semiconductor company developed in Cambridge by a few scientists that have long experience in semiconductor MEMS technology. Actually, some of our founders have already done some successful startups. And basically, with Flusso, they decided to stretch the technology in terms of flow sensing, and develop a very, very small high-performance sensor for high-volume, low-cost application. So we have been founded in 2016 as a spin-off of the University of Cambridge. And the intent of the company is to develop, design, and commercialize a really innovative sensor to really bring the flow technology to the next level. We have also a lot of strong links with the local ecosystem in Cambridge that are supporting us for development as well as mass manufacturing. We have a team of around 20 scientists and engineers, a lot of them with a lot of semiconductor industry experience, which bring really the company as a unique team to develop those kind of technology. Our first product, which is the FLS110 flow sensor, was announced in Q4 of 2020. and we are about to go in production in about 1 or 2 months, mass production. We have achieved ISO 9001 quality certification in December of 2020, which is a strong proof of the knowledge of the team and our capability to go into mass production in a few months. So where are the FLS110 flow sensor used so far? So due to its size and form factor, the Flusso technology is applicable to many different types of industries. So right now we have identified a key application in consumer appliances. So we are in prototypes with multiple large manufacturers of vacuum cleaners or air conditioning units or air purifiers. Again, the uniqueness of the Flusso sensor is well fitted for those type of application where you don't have a lot of space, where the products can be battery powered. We don't use a lot of energy with our Flusso sensor. And you can, if you design in the sensor, you can really save a lot of space into your end product. Also, we have identified some what we believe are very promising applications for smart buildings. As you know, the building industry is in the middle of the COVID pandemic, has to make a lot of changes, and there is a lot of new regulation or new push for back to work, back to the office. And we believe knowing exactly the flow in your ventilation system is a critical parameter that company will have to follow to make sure that the air quality inside the building are good, that the dilution is good with the outside air. And if you are monitoring for CO2 or for other gas, the flow indication is something very important as well. So it can be installed in HVAC system, part of the building systems, or it can also be installed in portable or fixed wall-mounted air purifiers or systems to again monitor the air quality inside the office. We have also multiple applications in the industrial space. It goes from, again, portable or fixed systems, but any device that is pumping air, such as gas detectors or personal monitors or air pump monitoring, having a real flow reading inside the device can be a critical performance differentiator. So we believe, again, the small size of the Flusso sensor is a key winning element for those applications. And last but not least, we have also some very strong requests from the healthcare industry. Could be related to the COVID situation, but not only. We have plenty of applications where the customer would like us to monitor the airflow or the gas flow in a portable or semi-portable system. For instance, to monitor patients at home, or in a pre-ICU situation for oxygenation monitoring, these kind of things. So again, you can see already a lot of application where having a very small form factor sensor, ultra low power, is a key differentiator to enable actually new application where no one has gone before. So if you look at this is our view, the Flusso view of the current challenges of air or gas flow measurement today, right? So we listed 5 here. The first one, we believe that the market price for current flow sensing solution is sometimes too expensive to really let customers with the need for flow measurement to actually take the cost of the flow sensor and decide to install a flow sensor inside their product. So we believe we are creating a little bit of a new type of flow sensing category, because when we have volume, we can really enable those customers to afford a sensor below $5, for instance, and today it's not just possible. The second challenge is that we see is sometimes the integration complexity. Most flow sensors that you can find today on the market are just a bit too big. They come at modules, And basically, you have to take their mechanical design into account into your product design. And sometimes they will impact your product design. So here, again, the form factor and size of the Flusso sensing technology will enable you to fit the sensor where it should be to have the best flow reading possible, while saving space and also integration cost, because you can design in the sensor. The third one is no choice of measurement basis. So the application performance depends on measuring in the correct basis. Most sensor will support actually only one basis. So again, Chris will go over in the next few slides the choice of measurement basis that you have with the Flusso technology. Again, this is to enable more application, more customers, but you can pretty much tell the Flusso sensor to give you the reading you want. We give you the firmware. We enable you to make the reading in the measurement basis that is most relevant for the application. The next one is a lot of products are in need of a flow measurement, but a lot of them, again, because sometimes of cost, a proxy is measured. So to approximate volume flow system, they often use expensive pumps, inaccurate oil sensor, or drift-prone pressure measurements. So again, we'll show you in the next few slides that we can provide a direct reading of the flow and not a proxy in that case. The last one, but which is actually very important today, in today's age of where the product development life cycles are tracked in any companies, as we know, the time to market is sometimes too long when you install the existing flow sensing technology. So again, we believe that measuring flow is not something which is as easy as other sensing techniques. And we are here to help you, guide you through your product development, help you design the flow sensor where it should be inside your product flow path. And by being a partner and not only a vendor, we can probably save you some times of integration, which is going to result in a shorter product development cycle for your end products. So this is again an overview of the challenges that the way we see it. And now we're going to let Chris dive into the Flusso technology and how we can help those different challenges one by one for you. And now I will hand it over to Chris to continue the presentation. Chris?
Thank you, Thomas. So as Thomas said, there are a number of different challenges with flow measurement in products. And what I'm going to talk to you about today is some of the unique technologies and solutions that we have come up with to address some of these challenges. So as Thomas mentioned, my name's Chris Rosser. I'm Flusso's Principal Fluidic Systems Engineer. And a big part of my role at Flusso is to help customers integrate our FLS110 flow sensing solution into their products as quickly, easily, and inexpensively as possible. And to help our customers do that, we have a number of different features that I'd like to talk to you about today. The first is the FLS110's shared architecture. So traditional fully integrated sensors incorporate electronics and processing into the sensing component themselves in a sort of monolithic design. This approach increases the system cost because it duplicates resources which are already present in the customer system elsewhere. In contrast, our flow sensor, the FLS110, makes use of resources such as ADCs, GPIOs, timers, and non-volatile memory on an existing microcontroller that's already in your system. And it also allows those resources to be shared between the FLS110 and other product functions. And this allows us to create a really significant improvement in the cost-performance ratio for our design. The FLS110 also offers really unparalleled versatility in flow measurement. It can be used to measure differential pressure, mass flow, volumetric flow, and airspeed, and it can do all that using exactly the same firmware and the same electronic components in all of these different applications. The firmware that we provide with the FLS110 as standard provides all of these options, but it can also be tailored even further to your specific application needs using our SDK, our software development kit. I'm going to talk a little bit more about the features of the software development kit later on. We believe that by standardizing on a single widely available platform for all of your different flow sensing needs, we can help you simplify your manufacturing and accelerate your time to market. And the image below shows a number of different flow sensing or airspeed sensing or differential pressure sensing solutions that you might be familiar with. And the FLS110 is able to replace all of those different modules simply by using a different fluidic fixture design. The FLS110 is the world's smallest flow sensor, and our really small footprint and very low component count makes it possible to install the FLS110 into even the most densely packed products with the most complex flow paths. This technology enables even smaller and more densely packed PCBs, and this provides a huge amount of product design flexibility, allowing you to customize the way that your product looks and the product size without having to worry about fitting very large modules into the design. And this can be particularly interesting for portable applications and wearable applications, where the overall envelope of the final product is really critical for market acceptance. Traditional mass flow sensors are often sold as modules with a flow fixture integrated into the component. And so you end up with something that looks like the image in the bottom left of this slide. It's a flow sensing component on a PCB integrated with a plastic flow fixture. Now, all of these extra parts, the extra electronic components that you can see on that PCB, the plastic flow fixture, all of these add a lot of cost to the flow sensing solution. And it also makes it really difficult to integrate that solution into space-constrained designs, particularly portable or wearable applications. In contrast, the FLS110 integrates into your existing design. And as you can see here, this green PCB would be the existing PCB that's already within your product. These other electronic components you can see here are all that is required to drive the FLS110, and obviously could be placed on the same board as the other electronic components required for your product. If we look also at the blue component, this blue component is also an existing part of the flow path in your product. It's an injection molded plastic part that you're already molding in order to carry the air through your product. Now, by adding a flow measurement feature to this blue plastic component, you can enable an accurate flow measurement with the FLS110. And we support many different flow measurement features, including an orifice plate, a venturi, or a laminar flow element. And you can see that the feature that's shown there in the blue plastic part is a small laminar flow element. Being so small, the FLS110 integrates easily into your existing flow path and into your existing design with minimal changes. And this reduces your development time and cost to bring the FLS110 flow sensing solution to market. As I spoke about before, the FLS110 is very configurable inside its firmware. We provide a standard firmware with the FLS110 that is less than 8K in size, that can be placed on the STM32M0 family of microcontrollers. But in addition to this pre-compiled firmware that we find is suitable for most use cases, we also provide a software development kit, or SDK, with the FLS110. Using this SDK, you can really customize FLS110 solutions for your exact application. For example, maybe you need to have a different interface to communicate with the microcontroller that drives the FLS110. Using our SDK, you can modify the firmware to support an application program interface if you want to run application code alongside our code in the same microcontroller, or I2C, SPI, Modbus, Serial. The options really are limitless. It's only your imagination and the imagination of the firmware developers who you've got working for you that limits what you can do with our SDK. Direct control of a pump or fan by the same microcontroller that is reading and driving the FLS110 is also possible by modifying the firmware that we provide using the SDK. Status indication, for example, indicating when to change filters or when a filter has become blocked, that's quite possible. And even more sophisticated integration with application functions using an API is easy to do using our SDK. You can have your application-specific code running alongside our firmware sensing code, our flow sensing code, and then use an API to enable those two pieces of firmware to communicate between each other to enable even more sophisticated solutions in your application. There's no one-size-fits-all calibration approach for flow sensing. We found that cost-sensitive applications cannot afford expensive multi-point calibration on every single unit that's manufactured. And that's simply because it adds too much time in production and too much cost for a high-volume consumer application. In contrast to that, system calibration is often required for high-performance applications to account for unit-to-unit variation in things like pumps and fans, in the geometry of your flow path, and in the sensing unit itself. The FLS110 firmware supports a whole range of system calibration options. From the lowest cost 0-point calibration, where no flow is required, that can be easily performed automatically at module test or first system power on, through single-point calibration, which we believe offers a great balance of performance and cost. Only a single known flow is required, and it can easily be integrated into end-of-line test where maybe you're running the motor in the product anyway. Or for a high precision application, we offer a full multi-point calibration, which supports multiple known flows, gives the best possible accuracy, and again is easily integrated into module test or end-of-line test. The FLS110 sensor also measures flow temperature and provides temperature compensated readings, so you can rely on the accuracy of the sensor even as the environmental temperature changes in your application. I'm now going to hand back over to Thomas, who's going to tell you a little bit more about the FLS110 Evaluation Kit. Thomas.
Thank you, Chris. So the FLS110 Evaluation Kit. So we have developed this kit for you, for our customer to test our technology. So this is a kit which has been available for about 6 months now. You can see on the top of the screen, you have basically a USB dongle that you can put on a laptop or a desktop computer. You have a cable, and then you have the FLS110 on a PCB attached to a flow fixture. So we can provide different flow fixture for you depending on your flow range or type of measurement you require. We have around 12 different flow fixture available in our flow fixture catalog that you can actually see on our website. Okay, you receive the kit usually within a week or two, and you download for free utility software on our website as well. That's going to let you enable the evaluation kit, make it work, but also do some data log. You can export to Excel. You can test our Flusso sensor against other flow sensors that you might be already using and assess the technology. This has been very successful for our customer to quickly test the performance of our Flusso sensor technology, and most of the time actually very successfully. It can be set up in usually in 10 minutes, And if you need some help, we can support you, set up a call with some of our application engineers to go through the process of opening the box to make it work in your setup. Because we believe this is a key part of the journey that you will have with Flusso. So we are actually offering a discount for all the people attending today's webinar. So if you want to order the kit, you can go on our website and click on evaluation form for the kit. You put your information and we will receive an email, and you just notify that you have been one of our attendees today, and we'll be more than happy to give you the discount. So you can really test our technology and make your own opinion. This offer will be valid for the next month or two, so you have plenty of time to decide which flow fixture you need and this kind of details. So this is about the evaluation kit. So next slide, Chris. So we are now towards the end of this presentation, and we will open up for Q&A. So feel free to put your questions in the chat on the right side. I can see that we have a few questions already coming in, and we will answer them the best we can. And again, if we don't have time to take all the questions, we will reply back to you by email in the next few hours. So Annie, can you look at the questions and let us know, please?
I certainly will. We have a question here that's very simply asking, how is the sensor powered?
Sure, so I can take that one. The sensor is powered by a 3.3 volt DC power, the same power supply that's used for the microcontroller that drives the sensor. So it's just a 3.3 volt DC power supply.
Super, thank you, Chris. And the next one that's coming up is, can the flow sensor be used in a gas testing system to measure the flow rate? And what are the ranges of values?
So absolutely, yes, the flow sensor can be used in a gas testing system. The flow sensor in a direct flow configuration can measure up to 200 cubic centimeters a minute. But in a bypass configuration, you can measure up to, well, we've had measurement above 500 liters a minute, and there's no reason why you couldn't extend that to any flow rate that you wanted in a bypass configuration.
Super, thank you. And the next one is saying, does the production schedule include the fixture or just the chip? Or do you expect customers to develop their own fixture?
Sure, so I can answer that one. Customers, we expect that customers will initially use the evaluation kit, which comes provided with a fixture, to try the sensor, see how they like it, check that it's going to work for their application. But at the point where they have selected the sensor and they wish to design that sensor in, we would expect them to integrate a suitable flow fixture into their product design. And by doing that, they'll really achieve the maximum cost savings. So we can assist with that, and we have some materials which can help with that designing process.
Okay, thank you very much. And the last one that I got so far is a little bit lengthy. So if used in a spirometer device, how would you recommend cleaning the device? Do you want to take that one first, and I'll do the second part of the question after?
Sure. So cleaning the sensor is quite possible. In the same way that you would clean a spirometer with something like isopropanol or isopropyl alcohol, you can also clean our sensor with IPA, and the procedure is just to ensure the sensor is powered off, and then flush through the sensor with isopropanol, 99% isopropanol, and then to allow the sensor to dry fully before you power it back on. And that's the approach for cleaning it.
Thank you very much. Would any contamination go in the sensor? CF and bronchitis patients are prone to infections would be able to use the sensor for those scenarios?
It's a great question. Obviously, the sensor is very small and has a tortuous path through it. So you would want to prevent any contamination getting into the sensor by the use of some sort of screen or filter on the inlet of the sensor. But if you were to do that, then the sensor should remain clear of contamination and should be safe to use, as safe as the rest of the flow path, provided that filter is able to prevent any ingress. And if you do get any ingress or contamination, as I said before, flushing the sensor through with 99% isopropanol or another cleaning chemical that's suitable for plastics should be fine.
Thank you, Chris. And there are no more questions coming in at this stage, so I think we can be closing up. Do you want to do that, Thomas?
Sure. So thanks again, everyone, for joining today's Flusso webinar. So we'll be holding webinars on a regular basis, and so stay tuned with us on our social media platform, LinkedIn, Twitter, and check your inbox as well to see what will be the next topic of webinar, and we'll be more than happy to host you again and answer your question, right? So I wish you a good day wherever you are, and let's talk again in a few weeks probably. Have a great day.